Hello everyone and welcome back to Mathematics with Usman. This is the first video in my series on the topic coordinate geometry. Students, there are certain objectives that we have to attain in this topic of coordinate geometry. Number 1, demonstrate familiarity with Cartesian coordinates in 2 dimensions. Number 2, find the gradient of the straight line. Number 3, calculate the gradient of a straight line from the coordinates of 2 points on it. Number 4, calculate the length and the coordinates of the midpoint of the line segment from the coordinates of its end points. Number 5, students, you have to interpret and obtain the equation of a straight line graph in the form of y equals mx plus c. Number 6, determine the equation of a straight line parallel to the given line. And the last one, find the gradient of parallel and perpendicular lines of this form. Find the equation of the line parallel to the equation y is equal to 4x minus 1 that passes through 0 minus 3, and so on and so forth. In today's tutorial, dear students, we are going to demonstrate familiarity with Cartesian coordinates in 2 dimensions. But before going into the topic, let us first talk what a big deal a coordinate geometry is, why is it so important, and why is it included in your GCSE syllabus. Geometry. As the name suggests, geometry means the study of the shapes, the study of the figures, the study of the lines and the points. But when it is not combined with the coordinate system, just look at this triangle. It is lying anywhere in the thin air and it has nothing to do with its position. But if we specify its coordinates or the vertices like this, A is having 2, 3 in reference to the vertex B, which is having the coordinates minus 4, 6. Randomly, I've just taken it randomly. Now, what you have done is you have specified the position of the figure in the coordinate systems. What coordinate geometry did is it combined 2 different fields. One, the geometry that deals with the figures, with the shapes, with the lines, with the points. And the second, coordinates that deal with numbers or the equations. And you have combined them together in one topic, coordinate geometry. Now what's happening is they are complementing one another. Means the figure or the shapes together with their equations. And that's why it is of the great importance to learn this coordinate geometry. And that's why we are digging deep into this topic. So let's start with the very basic. What it is? The 2 lines, vertical and the horizontal. Together, these 2 lines have the name. And what's the name? It's a French name called the Cartesian Plane. And plane doesn't mean something that flies. In fact, the plane over here means something that is flat. Just look at these 2 lines. They form a plane, smooth surface, which is a flat one. That's why this is named as Cartesian plane. And Cartesian, the word Cartesian is named after a very famous personality, a famous geometrist who was also a Frenchman, a guy pioneer working on it, and his name was René Descartes. It's difficult to pronounce, but this is how the French used to pronounce it. René Descartes. Let us now, students, straight away dig deep into this Cartesian plane. And if you look at it carefully, you can see that there is one point which is of great importance in the Cartesian plane. And that point is the center of these 2 lines right at the perpendicular bisector, this one. And I named it O because it is called a special named origin. Now, while dealing with the plane, there are 2 numbers that are of great importance other than the origin. And their 2 numbers are one in the horizontal line like this, and the one in the vertical line like this. but we won't call it the horizontal line, horizontal distance, or the vertical distance. We will give them a shorter name, x for the horizontal axis and y for the vertical axis. These two axes, the x-axis and the y-axis, and they are forming a plane, P-L-A-N-E, plane. What if we are having the three coordinates, and we can have them like the way in space we are living, we are breathing, we are living in the 3 dimensions. So we must have to add the third axis, and that is the z-axis. But we can't draw it here because our board or our screen is a 2D screen. Now after that, we have to mark certain points over here. See, this one, 1.1, this is the second point, this is the third point, and this is the fourth point. Here on the y-axis, we can also mark the points after every unit, 1, 2, and 3. But I won't suggest you to write the numbers on it, like 1, 2, 3 on the positive axis and minus 1, 2, 3 on the negative axis, because it make it very hard to understand all the information, all the other important information that we are looking on this coordinate system. Let us now consider any point which is lying somewhere in a plane over here. In order to identify the position of these points, what we have to look for is its horizontal distance and its vertical distance. If we look at it carefully, it is moving 1, 2 units in the x direction, 1, 2, and 3 units in the y direction. So this point, according to our scale, is going to be having the coordinates 2, 3. 2 units in the x direction and 3 units in the y direction. And students, remember, you always write the first coordinate as x and the second as y. Now there is one more point that I want to make over here is, what would be this unit and what can be the number for this? So you should remember, this can't be 5 or this can't be 10. What you have to do is, for every one small square which is 1 centimeter, if you are writing 1 for the first, 2 for the second, then you have to write 3 for the third. And for the y-axis, if you are writing 1 for the first, 2 for the second, 3 for the third, then we must have to put 4 for the fourth. What I want to say over here is, scale must be consistent on each axis. However, students, scale can be altered for x-axis and the y-axis if you like. For example, if we want to take 1 unit as 1 for the x-axis, you can take 1 centimeter or 1 small square for 2 units on the y-axis, or 1 centimeter for 10 on the y-axis and 1 centimeter for 1 unit on the x-axis. It means that for both the separate axes, scale can be different. I have used the word axes. What does it mean? Axes is the plural of axis, and we spell them the same, but we pronounce it axes so that we can separate both of them. Now let us consider another point which is lying on the left hand side of the y-axis. Now again we have to say its horizontal and the vertical distance, and the coordinates for it this times are -3 in the x direction and 3 in the y-axis. Just look at this, students. We have used the consistent scale for both the axes. Now your x-axis and the y-axis, they are dividing this whole plane into 4 equal parts, and we call them the quadrants. And what does the word quadrant means? As we use the word quadrant in the circle, quadrant or the quarter of the circle. Quadrant means 1 out of 4. So this is your first quadrant, this is your second quadrant, this is the third one, and here we are having the fourth one. Now if you look at the coordinates of A or this point over here, they both are positive for the first quadrant. X is negative and Y is positive. For the third one, X and Y both will be negative, and the fourth one, X is positive, however Y is negative in the fourth quadrant. This is how, students, you are going to mention, or you are going to write or draw any point in the plane, and you will combine all these planes to get different geometrical shapes. I hope you have better understanding of coordinate geometry now. And this brings us to the end of today's tutorial. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.